vector. So QR for one vector is just simply change the length. So what I'm going to add as an extra step in here is orthogonal, actually normal basis by doing QR. What's length of that vector? Square root of 1 squared plus 1 squared plus 0 is square root of 2. So 1 over the square root of 2 minus 1, 1, 0. That's the result of doing QR. How about here? Length of that vector is 1, nothing changes. And over here, I'll get a 1 over square root of 2, 1, 1, 0, the same thing. Before, we wrote an S-matrix out by using those vectors. These vectors are also a basis. I'll write the matrix out using these vectors instead. And since it's orthonormal columns, we'll call it Q as opposed to S. And lambda, the diagonal matrix that we get out of that is the eigenvalues equaling minus 2, 1, plus 2, 0, 0, 0, 0, 0, 0. Here is the table when I have an extra step of doing QR for each one of the eigensources. So next Wednesday, that's what we'll pull together, and we'll explain what the big application is, why that has something to do with that function. So for right now, the whole problem for you, once you know how to write down that matrix, the whole problem you already know. It's do the eigenvalue decomposition and add QR to it as an extra level over here. And then when you put the matrices together, pick the orthonormal vectors that you just got out of. That's that problem. So,
Professor, then sometimes, for instance, in the part B here, it's asking for the last sentence, last one.
So let Q be that. The terms positive definite, negative definite, indefinite have to do with the signs of the eigenvalues. Again, I'll explain next time.
Okay. And the last
And then orthogonally diagonalize the matrix corresponding to Q simply means that the decomposition that we found is A Q is equal to Q lambda. So I have to pull the inverse over to the other side, but what's the inverse of that matrix? It's an orthogonal matrix and it's square. The inverse of that matrix, Q inverse, is just Q transpose. Q lambda Q transpose. So the last statement is simply transcribe that equation into, well, what does this say about equals? Here, pulled off the A over, now it's equal. Slightly off. Is realize that what we've just done, this eigenvalue decomposition that we just did, since we fixed up the Q to have orthonormal columns, the inverse of that square matrix Q is just a transpose. So